Good morning all of you. My today's topic for the science, it's sound. Now we hear many sound in our day-to-day life. Maybe the sound of machines, the sound which is coming from our surrounding, the sound of birds, sound of animals, lots of sound we are hearing daily. Now what exactly the sound mean by? Sound is a sensation which is felt by our ears. We can call it as a vibration. So this is nothing but a sound. Now the question comes in our mind when someone is speaking and we are able to hear the sound. How we are able to hear this sound? It is all because of the sound is travel in the form of wave. Now suppose if we take one example, suppose here I have one glass of water and if in this water, if I add just pinch over this glass of water, then or in a pond of water, the still water is there. If the still water is there and if we throw a stone in that water, what will happen? We just see the patterns like this over this water, that the wave is transferring from the center to the side, from the center of this pond to the side of that pond. The wave get transferred. Now how exactly the wave is transferring from one point to other point? Here that the matters, or we can say particles present in that water particles, these water particles are transmitting the energy from one particle to other particle. Means there is a transfer of energy from one point to other point. Suppose in this pond here, this is the center of this pond and the energy is transferring from the center to the side of this pond. So it gets transmitted along the waves. So basically we are going to study here in this sound, we are going to study for the mechanical wave. So the first type, main type of the wave is mechanical wave, we are going to study here. Okay, now in this, what is mechanical wave? A wave is nothing but a disturbance of the particle or disturbance of the medium which has caused this mechanical wave. Mechanical wave again get in three types, again divided into three types. The first type is transverse wave. Next, second type is longitudinal waves. And the third type is surface wave. Now see, here the mechanical wave is nothing but a disturbance in the matter. Now mechanical wave again get classified into three types. The first is transverse wave, longitudinal wave and surface wave. So firstly we will see about the transverse wave. What exactly the transverse wave means? In transverse wave, the particles vibrate which is perpendicular to that of medium. Okay, so the first type we are going to see is transverse wave. Transverse wave. In that, the particle which is vibrating in the air medium which is perpendicular to that medium. Now suppose the transverse wave make this pattern. Here I am just drawing the diagram. So with the help of diagram you are going to understand. This is the origin. See, this is the medium density line, we can say. On the upper side higher density and the lower side which is lower density of this medium, and this wave is perpendicular. Here we can say it makes right angle triangle with this medium of the particles. So we can say the wave is called as transverse wave as it is perpendicular to the propagation or the medium of that, in which medium it is traveling. For the transverse wave, the basic property is the transverse wave travels only in solid and liquid. Only in solid and liquid. Now, the transverse wave is not travel in the gaseous medium. It requires only two mediums. The one is solid and another one is liquid. Now suppose when transverse wave is traveling, it firstly reaches to a peak point where the density is maximum. Again it goes to 0, again which is, we can say, perpendicular, then to the lower density, 0, again higher density. In this way the transverse wave travels. We can say this is a sine wave also, this transverse wave also. Now see some parameters of the transverse wave one by one we will see. Now see, in this transverse wave, the distance here we can able to see, I am denoting this distance as A. We can see it is the amplitude of this wave. Now what exactly mean by the amplitude? Amplitude is the maximum displacement of that particle from its mean position. From its mean position, the maximum displacement of that particular particle, we can call it as amplitude, and it is also the characteristics of this wave, transverse wave. Second, it is amplitude. Next, the time period. Suppose one crest and one trough, it complete. So we can say here this is the wavelength of this wave. One portion where the higher density of this medium it reaches, then again one lower density medium, so higher peak point, or this we can call it as crest, and the lower one we can call it as trough. So one crest, one trough, again crest, trough. The rotation will goes on as the wave is traveling in the solid and liquid. Transverse wave do not travel in the gaseous medium. Okay. Now here amplitude we saw, next one is crest, another one is trough. Crest is the part where higher density and the trough is a part where lower density. Next question comes in our mind that how we are going to calculate the wavelength of this wave. Now what exactly mean by wavelength? Wavelength is denoted by lambda. This is a sign of lambda. We can denote the wavelength by lambda. Now see the successive distance between two compression or two crest or two trough. We can say it as a wavelength. So one cycle will complete in one wavelength. Time, what is the time period for this wave then? Time period means the time required to complete the one crest and one trough is the time period of this transverse wave. So it is about the first wave, transverse wave. Next we come actual to our topic which is a longitudinal wave. Now what? Second type of the mechanical wave is longitudinal wave. Longitudinal wave is nothing but a sound wave, which is our all topic center of attraction, where it is a longitudinal wave. Longitudinal wave, when it is traveling in air or in any medium, it is parallel to that medium. So when the longitudinal waves traveling through a medium, then it creates compression as well as rarefaction. Now suppose if we take a spring, in that spring if we stretch that spring, then we can able to see the patterns like compression and rarefaction. Similarly here longitudinal wave, when the longitudinal waves travels, then it follows the patterns of compression and rarefaction. Okay, now see here. The particles, when it vibrates, it is parallel to the material medium or the particular matter medium. So here it is, when it is parallel, it forms the groups of compression and rarefaction. Okay, now what exactly mean by compression? Where the density is high, where the particle is compact with one another. So the density of that particular wave is high, this portion we can call it as compression. In transverse wave we called it as crossed. In this longitudinal wave, the second pattern where the density is weak, we can say where the density is less. So this pattern is called as rarefaction. So CR we can say rarefaction, and in transverse wave we can call it as a trub. So in transverse wave it is cross trub, but in longitudinal wave it is compression and rarefaction. So compression, rarefaction, compression, rarefaction. So this is the sound wave or longitudinal wave. Again, the characteristics of this wave. One by one we will see the characteristics. First is for amplitude. Second characteristics is wavelength. Third is time period. Fourth is frequency. And sixth is velocity, which is the important characteristics. Okay. Now, one by one also we are going to define for this longitudinal wave. So, the first is amplitude. Amplitude means the maximum displacement of that particle from this mean position. Here also, in this transverse wave also, in both the cases we can define amplitude. Here, as we increase the amplitude, then the distance from this mean position is higher. Similarly, if this distance is higher in rarefaction, it is also get more for the lower side. The next is wavelength. Wavelength means the distance between two consecutive compression or two rarefaction. Okay. Now see the distance between two consecutive compression or two consecutive rarefaction. We can define it as a wavelength, and see always wavelength we can denote it with the help of sign lambda, and we are measuring it in the unit meter or centimeter in CGS unit. In SI unit it is meter for wavelength. Next is time period. Third parameter is time period. Now the time taken by a wave to complete one cycle. Now how we define one cycle? That one, suppose here it, in this wave only we will see one compression and one rarefaction makes complete one cycle of this wave. One compression, one rarefaction of this longitudinal wave, or we can say sound wave, completes that the time period or the time required to complete one cycle, means one compression and one rarefaction. It is the time period of this particular wave. Second, the frequency. So on which parameter the frequency is depends? The parameters on which the frequency is depend is time period. So in 1 second, how many cycles get completed? Means how many compression and rarefaction get completed in 1 second is nothing but a frequency. So suppose here in 1 second 5 cycles can complete this wave. So this 5 cycles means we can say the frequency is 5 Hertz. Maybe 200 cycles they can complete. Cycles means one compression and one rarefaction. So we can see that one cycle get completed. So for this 1 second, how many cycle get completed? We can say that the frequency of this longitudinal wave. So the fourth parameter is frequency, and we can denote it with nu, and the unit for frequency is Hertz. The next parameter is velocity. Now you all know what is meant by velocity. Velocity is distance travelled per unit time, the rate of change of displacement per unit time. So here see distance travelled we can consider as a wavelength, and time period itself it is. So it is, we can say the velocity is equal to lambda upon t. So 1 upon t is nothing but a frequency. So here in this case sound wave we can consider it as a wavelength and time period. So 1 upon t is nothing but a frequency. Always remember students that frequency is equal to 1 upon time period. It is a reciprocal of time period. So it gets frequency is equal to 1 upon time period, that is t. So these are all the parameters of this longitudinal wave, which is a sound wave. Now second topic is how the sound wave get produced. Here we will conduct just one activity. Here you can see this is a tuning fork. This is one of the instruments of aluminium. We can call it as a tuning fork. When we stuck this tuning fork on this rubber pad, when we stuck this tuning fork on a rubber pad, a vibration is present or vibration is created in this tuning fork. So is the really, suppose if I am stucking this tuning fork on this rubber pad, then vibration get generated, and if we give this vibration, if we give the medium to this vibration, then we can able to feel this vibration. Now suppose for this activity I have taken here one glass of water, and this one glass of water I am using to produce the vibration. I am transferring this vibration to this one glass of water, so that there is a change in this water level or the vibration or wave you can able to see here directly. So everyone is ready for this experiment. Here I have the tuning fork of different frequencies. So tuning fork, it depends on their frequencies. See, so in 1 second how many vibrations it can get completed, it depends. This is the frequency parameter. Okay, in 1 second how many cycles it can get completed. It is the frequency also shown by the letter n also. Okay, sorry, here it is time period n also. So it is 1 upon t, which is a frequency. Now sir, I am just rubbing this tuning fork on the rubber pad. The vibration get produced. As soon as I touch this glass of water, the water is steel previously. As soon as I touch this tuning fork, you can able to see the waves are generated in the water. Again we can see a little bit water. If the highest vibration is at the point, so the water get displaced by some dots over here. So if I stuck the tuning fork and here applying, then it get the waves get transmitted in the liquid format. So with the help of this tuning fork, sound waves also be produced or it can be generated. This tuning fork is of different frequencies, but the material used for this tuning fork is of aluminium. Now I hope the activity get clear to everyone. So this tuning fork, how it produces the longitudinal wave. Now suppose this is a tuning fork. When we vibrate this tuning fork, it just changes its position. It as simple as it is. So it gets just displaced and starts vibrating. So vibration means there is a wave and there is a production of longitudinal wave, which is we can call it as a sound wave. So in this sound wave, how we are producing sound. Okay, next in this transverse wave and longitudinal waves, we have seen the parameters as well. Next we are going to look for that velocity. I already explained velocity is equal to that distance travel upon time period. We can also just modify this derivation by using 1 upon t is nothing but a frequency. So if we take as n is equal to frequency, so n is equal to 1 upon t. Well, v is equal to lambda upon t, which is nothing but v is equal to n lambda. So this is the formula for the velocity of sound in we can find in any medium. Longitudinal wave can travel in solid, liquid and gaseous also. But see, the speed of this longitudinal wave is greater in solid medium. Now, why it is greater in solid medium? The reason is why the speed is greater in solid medium, because in case of solid, the waves get or the particles get compact with each other. So, the wave can travel in the solid medium faster. But in case of liquid, just now we saw the activity that we have taken in the glass of water, but the wave traveled but very slowly. Suppose for this duster, if duster is a solid material, suppose if I stuck the tuning fork on duster and apply here, so I feel the vibration on the other side of this medium. Okay, where here suppose I am just stucking the rubber tuning fork and rubber pad, I can feel the vibration to the other side. So, and in case of liquid, so this tuning fork if I apply, then water get displaced. The travel of this wave is traveling, it is in the water, it is traveling, but I am not able to feel at the bottom. But in case of solid, I can feel. So, the speed of sound in solid is greater as compared to gaseous. Now, what exactly the value of this speed of sound in air? The value of speed of sound in air is 343 meter per second. By this speed, it can travel in the gaseous medium. Okay, so solid, liquid, gaseous, longitudinal wave can travel, but the transverse wave cannot travel through this solid, liquid and gaseous. Longitudinal waves travel in solid, liquid, gaseous, but transverse wave travel only in solid and liquid, not in gaseous. Next is surface wave. The third type is surface wave. In this surface wave, we can say it as a seismic wave. Surface wave is nothing but a seismic wave. It is used to denote we get to know that the earthquakes informations. So we can say it as a seismic wave, or P wave also we can say this surface wave. Okay, we can able to see the surface wave in seismic wave for the earthquake notation, and we can call it this wave also as a P wave. Now, the third point is, see, as like we have seen how the sound get produced, what is mean by wave, what is sound wave. Longitudinal wave is nothing but a sound wave. But now we are going to see for how the reflection of sound is there. Now, reflection, as like a light, in sound also reflection is there. Suppose if I am speaking something at this wall, particular to the benches, my voice gets stuck and it gets reflected at the same angle. As like in light, we also have a laws of reflection. Similarly, in case of sound also, we have the laws of reflection. So, in case of suppose a sound incident here, this is normal and it get reflected. Here it is normal, it is reflecting surface. So, as the sound get incident, sound waves and the reflected waves are there. So, incident wave and reflected wave. The angle made by normal and incident wave, both are always equal. So, the sound angle made by sound wave, incident sound wave and reflected sound wave, it's always equal, and the incident sound wave, normal and reflected sound wave lies in one plane. This two law, similarly in case of light and sound, both the laws can be verified, or it obeys both the laws. Similarly, what is when fire get burned? What we get earlier, sound or light? I want answers. Okay, so the we can able to see the light firstly, and then we can able to hear the sound. Similarly, if a gun get fired, same thing, we can able to see the light first and then the sound later earlier. So similarly in refracting, laws get followed as like a light and sound. Both the reflected waves of the sound, incident wave and normal, lies in the one plane. Okay, and the second, the angle is equal. Now what is the application of this reflection of sound? Have you seen the megaphone? In megaphones also the sound get reflected and it get loud to other side. In stethoscope also, the continuously reflection is there. If it is the wire of the stethoscope, we all know that we are using it to listen the heartbeats. Also, now suppose if we are using stethoscope, then there is a continuously reflection will be there, and due to this continuous reflection, the doctor can able to hear the sound of heartbeat. So reflection is having a megaphone, microphone, are the lots of day-to-day life examples are there or applications are there for the reflection of sound. Okay, so in stethoscope, when the doctor is using it to listen the heartbeat, then in this wire of the stethoscope, the material used such that so that there is a continuous reflection of sound will be there, and this heartbeat can properly heard by that doctor. So reflection of sound is also used in auditorium hall. Auditorium hall also built, or the construction is like that, the roof are like that, so that there is a continuous reflection of the sound will occurs there, so that the listener can listen the sound properly. Suppose if in open space, if I am speaking, so other students or other person or the person same width if we are taking as compared to auditorium, then we are not able to hear that sound that much clearly or properly. But in case of auditorium, due to that roof made such that there is a continuous reflection of the sound occurs, and we can call this term as reverberation. Also, in this reverberation comes under this reflection of sound. One more reflection, suppose if we shout from a hill or from a mountain, then what happened? The same sound we are hearing again and again. Yes or no? So this is nothing but a echo. It is also the term of this sound. We can able to hear the echo. It has some applications. Now why the sound is coming again? That it is due to that reflection of the sound. Okay, now what exactly the reflection occurs there? It has a particular distance. Which distance it is, how by how many, at how many particular space we can able to hear the echo. It is not the way that at every place we can hear the echo. At some particular height only the range is there. Similarly, the range for the human, what is the range for the human being can hear the sound? The range is 20 Hertz to 20 kilohertz. The sound below 20 Hertz we cannot able to hear. The sound above 20 Hertz we cannot able to hear. There are many types of sounds are there. Audible, unaudible, pleasant, soft, maybe the music tone, the sound from the music instruments, the sound from the piano. Suppose if we take the example of the sound from the piano, it is a pleasant and soft, soft sound we can able to hear. Similarly, the frequency of the audible sound is 20 Hertz to 20 kilohertz. Now see, 20 Hertz and 20 kilohertz, this is the fixed range of the sound which can be heard by human. But what if the sound is below less than 20 hertz. If it is less than 20 hertz, then we can call this sound as infrasonic. Infrasonic sound. And the sound which is greater than 20 hertz, we can call it as ultrasound. So 20 hertz to 20 kilohertz is the sound of audible frequency which human can hear. Below 20 hertz, we humans cannot be here. So below 20 hertz, we can call this as infrasonic sound, and above or greater than 20 hertz, we can call it as a ultrasound. So this is the frequency which human can hear, between 20 hertz to 20 kilohertz. Okay, means 20,000 hertz we can say. So that much large frequency is can be audible by human ear. So it is infrasonic and ultrasound. So in this sound, acoustics branch, we have wide application of ultrasound. Sonar, it is also the application of ultrasound. We are using ultrasound for different application. Also infrasonic sound can be heard by the animals.